Welcome to episode 103, Gas Stations in Space, How Orbit Fab is Enabling Spacecraft to Refueling Technology. So this episode is very close to my heart because I'm a very much fan of science fiction. For me, this was a science fiction previously until Orbit Fab made it a dream turn into a reality, basically. So I've been like excited to record this episode because previously we never really had an episode which is offbit other than just launching the satellites or looking at the Earth observation or the satellite communication. This is something where we are extending the life of the existing satellites, and trying to make a difference in the industry, kind of moving towards the sustainable part as well. So without any delay, I would like to welcome the CEO and the co-founder of Orbit Fab, Daniel Faber. Hi Daniel, welcome to the podcast.
Hi, Onka. Great to be here.
Thank you very much, Daniel, for your precious time. And I believe it's been an exciting time in the industry. The way things are going at the moment, we have seen investments increasing. We are seeing a new pathways also coming up. I recently saw there is one company who's trying to generate a solar power from the space as well. So quite an exciting time I feel going on. And in that, Orbit Fab is one of the companies I see that trying to make a lot of difference. I would say it's not a small thing that you guys are doing at the moment. So before we actually take a jump into this topic, I would like to basically know a little bit about your journey, because turning something that was a science fiction concept into a reality it takes a lot of hard work, a passionate kind of team as well. So I would like to ask you this, like, when did you first realize your passion for space, and what is it about space that has captured your imagination, and of course your innovative spirit that has ultimately led to the foundation of Orbit Fab?
Yeah, I grew up on a farm in Tasmania at the bottom of the world, and but I had an engineer for a father and a chemist as a mother. So maybe I was doomed to do something technical. We had a wall of science fiction. So I also perhaps read a bit too much science fiction. But when I went to university in Sydney, I did engineering. And I was thinking, what do I want to do with my life? I want to do something that will help humanity and make a positive impact. I want to do something that will be interesting as a career. And started thinking about addressing existential risks and realized if we can make humanity interplanetary, we'll address a lot of existential risks. And so that was when I decided, how do we create the first permanent jobs in space? How do we start moving people into space? How do we do it economically sustainable? We need a bustling economy in space. And so I wrote down a list of industries that I thought could pay for the first permanent jobs in space. It was a very short list. It was tourism and mining and space-based solar power. But at the time, I did the math, and space-based solar power didn't work. This is 25 years ago. So I decided I wasn't really cut out to be a tour operator. I would work away on things related to asteroid mining. So I helped build a dozen satellites around the world, and then started building companies. Orbit Fab is the fourth company, and it's all about building that bustling in space economy that one day can support permanent jobs and allow us to move off of Earth.
Interesting. That's a quite an interesting journey. And by the way, I came to know today that this is your fourth company. I was not aware about this. So that's a quite a lot of foundation, I think, you have been building to reach to this point. So I would like now to directly get into the topic. The thing, Orbit Fab. So we know Orbit Fab is known as the gas stations company, I would say, which is supplying out or refueling the satellites. So if you're building or launching gas stations in space, you must be anticipating a real need for refueling the satellites and spacecraft, and ultimately an entire space economy. So what are your thoughts on how basically you develop this concept and try to make it economically viable, because we see a lot of big giants are basically interested to partner with your company, or you already have demonstrated one successful mission as well. So can you bit elaborate on this part?
Yeah, absolutely. But before we started the company, we'd sold the previous company. I was looking at what we could do as the next most impactful thing. So, at my last company, we were building small thrusters to move satellites around in orbit that could run off material that one day you might get out of an asteroid. And so, this was hoping to build the demand that one day might be able to support asteroid mining. So when I was looking at various different things, I sort of stepped back and sort of expand the vision. What is the most impactful thing to work on? Um, I started talking to potential customers and users. And one of the things we were looking at was perhaps a space commodities exchange where some countries would buy the first 10,000 tons of asteroid derived material and underwrite the building of a delivery terminal. But that was going very slow because the governments, of course, were wanted to be sure and will it build into the policy, all the types of economic benefits and everything else. So this was going to take time. So I just went out to the companies that might use that material and said, what would you buy? Where would you buy it? How would you buy it? And then the most important question, what would be the marginal revenue you could get if you had 1 extra kilogram of propellant in orbit? And I was absolutely shocked when the answer came back at $1 million per kilogram. And because I know the launch companies, like I can probably get a creative deal. The cost of launch is falling. We could get to orbit for $1 to $10,000 a kilo. We're creating 3 orders of magnitude value here. 3 orders of magnitude arbitrage that's a huge number. And so I thought, well, clearly we can put a business inside of this. And it was on the back of 7 or 8 calls with customers where I kept hearing again and again the marginal value is about $1 million per kilogram of propellant. So that was amazing. And then a couple of years later, there was an article published by Space Force in Space Force Association Journal saying that just on the delayed asset replacement, fuel for US Space Force would be worth $800,000 per kilogram. So I kept seeing this number being backed up. So that's really why Orbit Fab exists, is a response to that demand and the opportunity to just create that value.
Interesting. I mean, that's a classic combination of, entrepreneurship and space technology, as you mentioned in between why, when, and how. I think this questions when we try to answer it in a deep manner, especially looking at the space exploration and the kind of future we are looking at in the space domain, it really brings us to the head-on point, of to balance out the values of both the economics as well as the technology. Because I feel, I mean, in this day and age, Orbit Fab also found the success because I think we are living in a day and age where commercial companies are also, kind of encouraged by the government at the moment. I mean, SpaceX is an example where, it took them almost more than 15 years to basically become what they have. But yeah, even though I feel, what you guys are doing is still more complex than what SpaceX is doing, because launching business is something very much common on the terrestrial grounds at the moment. But yeah, moving ahead into the conversation. So satellite and spacecraft have been launched into space for more than 50 years without the ability to, fill up at, any gas station. I mean, we don't have any existing gas stations apart from, Orbit Fab at the moment. So why is it increasingly becoming important, and that, this spacecraft need to be fueled, and what is the kind of impact it will have on the future space economy?
Yeah, if you think you mentioned SpaceX there, if you think of what they've done with reusable rockets and how that's been able to drive down the cost of launch, and any launch company now that doesn't have reusable rockets is running into a dead end,
Yes.
right? This is the new paradigm now, and don't underestimate how complicated rockets are.
Yes.
I've only ever worked on the things
Yes.
that go on the end of rockets. Perhaps I'm not smart enough to work on the
Yes.
rockets themselves, but we're trying to do the same thing. How do we make satellites reusable? And it's not just right at the beginning, you talked about life extension. It's not just life extension for those satellites. It's the ability to do things with satellites we've never been able to. When we started launching satellites 60 years ago, all the satellites were like, it's incredibly expensive. And all the satellites had 1 tank of fuel, and there wasn't the technology to dock satellites together. We got that through the space station programs and through the manned programs where there was a human in the loop and we were able to do that. They started developing robotic technology. That now exists. So we are able to dock spacecraft together autonomously. And that means we can have spacecraft interacting. You start to be able to do repairs and upgrades and tugging spacecraft between vehicles, removing debris, and then people talk about recycling when you can collect the material together and manufacturing in orbit and being able to return things to the ground. These are things that need fuel to move around. We've been in this paradigm where we've only had 1 tank of fuel, and the engineers in the industry have become very good, absolutely brilliant, and maximizing what they can get from 1 tank of fuel. But you do it by compromising what you can do on the operations. You try to stand as still as possible
Absolutely.
and you don't move unless you have to, and you come up with a whole bunch of ways to operate without using fuel. Once you remove that limitation, you start to be able to do so much more. We see new business models coming up every day for things. We generally use the term satellite servicing, but it's servicing, assembly, manufacturing,
Yes.
logistics. Everything is coming up on the ability to have satellites work together. When we started Orbit Fab, there were 5 or 6 companies that were working on, I call them tow trucks in space, different servicing concepts. We lost count 2 years ago when that number passed 200. It's been an incredible expansion of just the ideas that people have had because that paradigm is breaking.
Interesting. And I mean, you mentioned the way things are working at the moment. Can we also take a deep dive into the technical side? Because the technical aspect is something that makes this concept very much complex. But you guys have achieved success, and that's a big leap, I would say, at the moment. So, can you explain briefly about the technical innovations that Orbit Fab has done to bring this technology into existence, and then successfully again demonstrating it as well?
Hmm. Yeah, we when we started, we looked at a couple of different ways to refuel satellites. One is to look at the legacy satellites and to try to add fuel to them. But they're filled with a valve which is then capped off and tied down with lock wire. It's quite complicated. NASA put together a robotic mission to go and do satellite surgery to try and cut into those lines and add extra fuel to an old satellite. And they spent $1.5 billion before realizing it was so expensive they were going to have to cancel that program. It's very, very hard to do robotic surgery on a satellite in space. We took the different approach, which was to say we can only refuel things that take the right gas cap. And that gas cap didn't exist. But we've now invented this. We've brought this to market. It's commercially available. It's been accepted by US Space Force for use on national security missions. It's being used internationally as well. And so this gas cap, this never existed before. It has to accomplish a lot of different things, not just be able to transfer fuel, but based on the tests we did on the space station, based on the first fuel depot we had in orbit, we designed an architecture to provide the lowest cost refueling. And we've been very focused. This is a logistics business and it's all about cost. So there is no robot arm requirement in our system. It can directly dock. The active side, the nozzle, is a 4-finger gripper. So we've done that. We did a big analysis on where we should put the depots, how we should do the depots, what size we should have. And I use the word depot, but really we don't need to collect the tanks into one place. We need to distribute them near where the customers are. And so there's a lot of things that go into that architecture which allow it to be low cost. So some of the innovations we have, the gas cap and the nozzle is the most important thing that we're doing. And then the architecture and the logistics chain is the second important thing that we're doing. One thing that we decided not to do was the rendezvous and docking technology. So I mentioned before that's been done under various government programs that supported the development of that technology. That now exists. But there are companies that are looking to turn that into a product. So you can buy a box to put on your spacecraft with all the sensors and the algorithms and the compute boards and everything that will make your satellite a self-driving satellite. In the same way, 10 years ago, people started thinking about self-driving cars, and for the first few years, the first thing you had to do was make your own self-driving car. Then people came out with a kit, and in a couple of months, you could buy a car, you could put the kit on it, and you could make a self-driving car because the kit existed. Everything went so much faster. So that's what now multiple companies are looking to provide, that rendezvous and docking kit, so you can make your satellite capable of interacting with other satellites. We want to see that exist, so we're buying that from some of the companies that we think are the most prospective to successfully productize that. So that's an innovation that's happening in the industry outside of what we're doing, and is really adding to this ecosystem that we're building.
That's quite interesting to know. So, you mean it's kind of a plug and play solutions that are coming into existence in the in orbit servicing at the moment.
That's right. This is the whole ecosystem that's growing right now, the capability that's being built so that people who have applications, people that want to build recycling, can buy a tow truck to go and collect all of the
Wow.
debris that's in orbit to then run the recycling. And they can focus on the hard tech of recycling because somebody's already solved the hard tech of the debris collection vehicle and the refueling for that vehicle and everything else that needs to go in. So this is how a real ecosystem grows up with a lot of companies contributing.
That's quite amazing, I would say. And because I'm personally deal with the supply chain management in the space industry, so I'm quite excited to ask you this question. So can you also elaborate a bit about your rafty refueling port and grip refueling nozzle as well? Because I think these are the I think very much important components, especially the components from where the refueling happens. It's quite, I would say, a critical component in your system. So can you bit elaborate on these two parts?
Yeah, absolutely. So the nozzle, I don't have one here at hand to be able to show you. The nozzle, it's about yay big. It's
Yeah.
about the same size and weight as two valves that they would use to fill and drain the tanks at the moment on the ground. So you have to have these valves to fill the satellite. You need one, for example, for hydrazine and one for pressurant, or one for nitrous, one for ethane, depending on what you have. You typically need two of these valves. So we packaged that and said, okay, it's the same size, weight, and cost, just use it as a replacement and use it as a fill drain valve, even if you don't plan to refuel in orbit. And then you have the option if you ever want it. But that way, we want to just get it built into every satellite. And we went then to the supply chain for those fill drain valves. There are companies that make them. If you want to build a satellite, you need with a propulsion system, you need a valve. You will go to three or four of the main suppliers and say, what are the options? And do a trade study and buy the best valve. So we went to those companies and said, why don't you manufacture this valve and sell this valve,
Okay.
and it'll become just the default valve, and it gets built into the supply chains. So we are licensing that. If any companies are making valves and want to license the production of the Rafty gas cap, then we make that available. And then also we take the nozzle, which is a more complex, it's a robotic hand with all the refueling parts in it. We take that nozzle, it's complicated. We're building that at the moment, but we're also making that available to companies that have servicing vehicles like tow trucks. If they want to add a refueling capability to their tow truck to be able to refuel everybody who's got the gas caps now. So we're partnering with Astroscale and ClearSpace and other companies that want to create that capability onto their servicing vehicles. And so we're really collaborating with a lot of different people to bring this to fruition. The same time, we're building our own capability to get the fuel to orbit, to build a logistics supply chain to launch on any launch vehicle, where the load factors on launch vehicles are 50 to 60%. It's absolutely shocking. Even though launch is the critical thing, it's so expensive, it slows everything down in the industry. Still, because of the way you need to hold contingency, because of the way licensing happens and regulation, all of these things cause you not to be able to fill up the rocket.
Yes.
So we go to the launch companies, and say, we have a standard fuel depot. It's like a Lego brick. It's the same size. It's been analyzed. Everybody knows what it is. How about you put these on at the last minute? We'll help you monetize every last gram of your launch vehicle. And in that way, we'll get fuel to orbit, which may end up being cheaper than what anybody could launch it even inside their tanks. And so this is part of our efficient logistics chain then, is how we build this up. So you can start to see there's a lot of different moving parts here, but it all has to fit together in a business model that makes sense.
Interesting. That's very interesting to know. I think licensing of the product can kind of expand the supply chain, and basically you'll be a benchmarking company when it comes to this kind of components in the future. For sure.
That's one of the options for the business model for Orbit Fab.
Yes.
Yep.
And moving forward, I would say a little bit coming out of the technical part, are commercial and government missions integrating Orbit Fab's refueling interfaces on spacecraft today? And when are the first refuelable missions set to launch into space? Where we can see more and more private participation, or there are several satellite operators like maybe SES or maybe Eutelsat. There are several new constellations which are coming up. So can we see the participation of Orbit Fab in such new constellations where you might be refueling the satellites over there?
Yeah, absolutely. We've shipped the fueling ports now to Europe, Japan, around North America for people to integrate into spacecraft. So we're seeing that getting designed in and getting built into spacecraft that are being launched very soon. It was only past the flight qualification earlier this year, so it's only been shipping this year so far. But it's also been accepted by, like I mentioned, the U.S. government for inclusion in U.S. government satellite missions, and so a lot of our sales are to the US government. So this adoption is starting to happen. And as early as next year, we're going to start to see satellites in orbit that have the fueling port that are starting to be then part of that refuelable ecosystem. And the more that's included, the easier the logistics becomes to be able to refuel everybody.
Absolutely. And I believe as we proceed ahead, we'll see more and more participation from the government, because I believe, especially, I mean, I'm originally from India, and we see the Indian government still sticking to the geo satellites, especially, for their armed forces. So, and I mean, geo satellites are going nowhere. Let's face this fact for the military, especially, I would say, because those are heavy satellites, and they can last for longer than other satellites. So I think, do you also are looking at the international military customers, because we see that the United States is now cooperating with countries like India, Japan, for the military cooperation. There are several agreements that are happening. The Indian astronaut is flying as well on the US company's space model. So do you see this kind of direction, where you'll be, apart from helping the commercial companies, where you can also have a focus on dedicatedly on the military satellites, because those are the heavy machine system, and I believe that's where even the revenue generation model can basically scale up for Orbit Fab. So can you provide your thoughts on this?
Yeah, we definitely see that that interest internationally. Like I mentioned, we're shipping the fuel imports already internationally, and I think that a lot of governments that are allies want to be compatible. So this helps them to be compatible, and then if something happens and they need more fuel, they can all get fuel and interchange fuel, which is important. So yeah, that's definitely part of what's driving this is the national security side. And if you can outmaneuver somebody today, but you've only got one tank of fuel, then you're a sitting duck tomorrow. That's a reality that a lot of people want to change, and so that's part of what we're helping them to bring on that capability. That's been quite critical on the commercial side. And you mentioned low Earth orbit versus geostationary orbit. There are big assets in geo, and there's a point where apertures matter, right?
Yes.
Size matters
Yes.
for a lot of things. I don't ever see that going away. The position of a geostationary satellite is useful. The size of equipment that you can aggregate up there when you can connect things together, which is coming, right? That's really useful, and I expect to see geo engineering models double down on economies of scale
Yes.
and just increasing the apertures of everything that's available, and thereby increasing the capabilities. And that's going to be true commercial and government applications. In
Absolutely.
low Earth orbit, we have proliferation of small spacecraft. And so now there are constellations planned with hundreds of thousands of small satellites, and constellations deployed now with thousands of
Yes.
satellites. And so those have typically started out very small as the companies had to figure out product market fit. But then once they find that product market fit, economies of scale mean that the spacecraft do get bigger. So if you look at Planet Labs with remote sensing, they started out with the Doves, very, very small. And the latest super Doves and SkySats and things are already getting bigger.
Yes.
If you look at SpaceX, they started with a satellite a couple of 100 kilos, and the latest generation are almost a ton.
Yes.
And consequently, the amount of fuel on those spacecraft has gone up considerably as well. And so we see this trend combining with satellite servicing in a very interesting way. If you compare to terrestrial communications, you have a cell phone tower, and when you want to upgrade from 4G to 5G,
Yeah.
you take off the 4G transponders, you put on the 5G transponders. You don't have to rebuild the hill,
Absolutely.
you don't have to rebuild the tower, you don't have to put in rebuild the fiber optic connection, you don't have to put in the power connection, right? It's all there. You just upgrade the transponder. We sat down with the chief of supply chain for one of the mega constellation companies, and he did his math when we described the architecture. And he concluded that their current plan of refreshing their constellation every 5 years for $5 to $10 billion, which takes them 5 years to design and build a satellite factory to be able to efficiently produce spacecraft, and it's highly integrated, highly engineered things. That model costs them $5 or $10 billion. Takes 5 years. If you have satellite cell phone towers in orbit, then you all you have to do is build the transponders
Yes.
and launch them and get them attached. And his conclusion was you could do that for $500 million, and you could do it in less than a year. So a factor of 10 cheaper and a factor of 5 faster.
Yes.
The result of this is that you can drive the cost of telecommunications through satellites down another order of magnitude or more. And that allows you then to move the bulk of the $2.7 trillion telecoms industry into space. Now we need a network of hundreds of thousands or millions of cell phone towers, just like we have on Earth.
Yes.
We need those in space. They need to be serviced by a tow truck company that can remove and install those transponders and those antennas. And all of those need fuel. The towers need fuel because they're going to have to be keep coordinated, keep out of each other's way, avoid debris and those types of things. So we're in this position now at Orbit Fab. It's very interesting that we can help provide one of the fundamental pieces that are needed to create that business model. And as we prove out the unit economics on this, and as the satellite servicing companies will prove out the unit economics on upgradable payloads and installs, etc., on spacecraft, someone will be able to sit down and do the math and say, right, now I'm going to build 100,000 cell phone towers in orbit, and I'm going to lease out the transponders for 30-year leases and the space on these vehicles, and it's going to make an incredible business. That's one of the more exciting commercial opportunities that I see right now. It's going to completely upend the way that we do satellites in low Earth orbit.
Interesting. I mean, that example of cell phone towers is very amazing because I believe a lot of people working in the downstream segment of the satellite services will be able to understand the way upstream market operates. So that's an excellent example, I would say. And I think we are almost at the end of the podcast at the moment. So I'd like to take this opportunity to kind of generally ask you about the overall aspect of Orbit Fab. So, what is Orbit Fab's overall objective, and how close are you to fulfilling that goal, especially enabling your customer dreams and visions that are needed to be realized? And as well as of course, your own visions and what you would like to expand it into in the future. Because I don't believe a person like you, who has seen such different walks of life in the industry, will just stop here. I believe you will keep on evolving. So, yeah, can you briefly mention what is your future vision as well for the company?
Yeah, mate, I described at the beginning why I got into this, and that's still my
Yeah.
vision: a bustling in space economy that can support permanent jobs in space. So that's Orbit Fab's vision as well, creating a bustling in space economy. Our mission in this is to create the industrial chemicals supply chain. So it starts with the propellant supply chain, and the gas stations in space is a great tagline. But what we want to do is it looks more like a downstream oil and gas company: refineries, storage, and distribution of industrial chemicals. So one day we'd like to build the refineries. Right now we're building storage and distribution.
Yes.
But we would like to become the biggest customer of asteroid and moon mined material. We'd like to process that material into the industrial chemicals that people want to buy, where a large portion of that is propellant, but the in-space manufacturing is going to need different types of industrial chemicals. The foundries in orbit, the companies that make products in orbit, the people that are living and needing air and water and food. They need minerals for growing plants. They need 3D printer feedstock. All of those industrial chemicals, that's the 20-year vision of Orbit Fab, is to be a dominant industrial chemical supply company in orbit.
Thank you. Thank you very much, for this wonderful insights, I would say. And I believe this episode, more than information, is going to be an inspiration as well, especially for the people, who are listening from the non-space side, because there is a population from the defense industry who are trying to get into the space industry as well, both, from the strategists and the entrepreneurs too. So this episode, I believe, will serve not only as informative and technically, loaded in terms of knowledge, but also an inspiration, of basically what more can be done in the space industry. There are different verticals to innovate, to provide solutions, to make this industry more sustainable, basically. So thank you very much, Daniel, for providing such wonderful insights, and I hope we record more such episodes in the future. Because I believe there is a lot to explore as you proceed ahead with the evolution. As you said, you're just building the storage at the moment and the distribution, but there are some other things also you're going to build in terms of refining the products and refining the solutions as well. So I hope we reach that point and we'll be able to record more episodes with you in the future as we come up with new solutions. So yeah, thank you very much again, Daniel, for this time.
Thank you, Omkar. That'd be great. It'd be great to be back in a bit when be able to report on the progress.
Absolutely.